So I was thinking today that about the fact that fractions are not numbers and division by zero is a problem for math. Now, um, this actually confirms that fractions are not numbers when you think about it. So, right, what you got is a conventional claim that these ratios between things, right, the rationals, that's why they're called that, um, are numbers. Okay. If that were true, then all ratios should be a number, right? But any ratio with a zero on the bottom is not a number under the standard claim that ratios are numbers. It doesn't even work within its own context. Which is interesting because a ratio with a zero on the bottom is actually exactly the same thing as its inverse, which we can get a number out of, uh, allegedly, under the classical analysis, right? So 0 divided by 4, which is fine, but 4 divided by 0 gives us trash, right? But now think about this in terms of a real world situation, right? Where you're getting a 4 divided by 0 is going to be in something like a win-loss record for a team. So say we have, some fictional toy like football league or something with only 2 teams on it. So, and one of the teams just wins every time, and the other one loses every time, right? Very simple, right? So they play 6 games. So one team has a win-loss ratio of 6-0. It's 6-0, and the other one is 0-6, right? It's exactly the same ratio. But if we were to treat it as a division problem, one of them is 6 divided by 0, and the other one is 0 divided by 6. It's the same exact thing. But if we're trying to look at it through the lens of conventional mathematics, viewing one of them comes out as a number, allegedly, and the other one comes out as unanalyzable. We don't know anything about it. And undefined, not a number, something like that. But they're exactly the same thing. So there's something missing in this account. And I think fundamentally what it is that none of these are numbers. They're all just ratios between 2 different things. They're not numbers. So 1/3 is not a number. It's 1 out of 3. 2/6 is not a number, and more importantly, it's not the same number as 1/3. It's it's not the same thing as 1/3, right? It's a different ratio. It's 2 out of 6, not 1 out of 3. You can abstract them as being the same thing. But whenever you make an abstraction like this, you're losing information, right? So originally they are different from each other, as I've noted in previous videos. They are distinct from each other. 2/6 is distinct from 1/3. The units are different. The number of instances of the units are different. They are different things from each other. And if it's just a ratio of stuff, the inverse of it should also make sense, right? So say we've got, like a little gas generator, a little, electric generator that runs like petrol, gasoline. How many miles per gallon does it get? Well, it doesn't move. So 0? Okay, so say we've got this generator running and it consumes 1 gallon per hour. Okay. Now we put it on the back of a truck and we drive that truck at an average speed of 30 miles an hour for an hour. How many miles per gallon does the generator get? Well, it went 30 miles in an hour, and it uses a gallon an hour, so it gets a gallon every 30 miles, right? 30 miles per gallon? This is the same thing, or isn't it? Gallon per mile per gallon. It's just a different way of expressing the same relationship. But now if we leave it sitting still, so it gets 0 miles per gallon. Okay. We're okay thinking of that as a number. But if we flip it, gallons per mile, how many gallons does it get per mile? Well, it doesn't move. So the question doesn't make sense. But there's a reason it doesn't make sense. Sometimes questions like this do make sense, like win-loss ratios. And this is why division by 0 is a problem for math, but it also highlights that these things aren't numbers, right? You cannot simply reduce it to the abstraction of it being a number, because there's too much else there. There's context. The units matter to the logic of what the fuck is happening. If you throw away the units and try to get it to just be a scalar, it doesn't make sense anymore. You can't get anything out of that. It doesn't mean anything. So it's not a number. It's still a vector. It still has units attached to it. It still has dimension, right? A vector has dimension. A scalar number doesn't. It's just a scalar. It's just a number. It has no dimension. Because once we put a dimension on it, now it's something different from a number. That's right. That's the power of numbers, is that you can use it to quantify something in any sort of dimension, right? We can have 7 cats or 7 bottles of beer on the wall or whatever the fuck, right? Once you connect the dimension to it, it's not a number anymore. It's a vector, right? The unit makes it a vector. And the only way we can make sense of fractions in real life, ratios in real life, is to keep in mind what the units are. What unit is being divided by what unit? And when you do that, you can determine when division by 0 doesn't make sense. Or you can, right, because so like the generator, how many gallons per mile does it get? That doesn't make sense, because it doesn't move. At least it doesn't move under its own power. And generally what this question is going to be asking is how many gallons does it use to travel a mile under its own power? And it doesn't move, so this question doesn't make sense. But when you understand what the units are, it's obvious why it doesn't make sense. If we were just trying to figure out what the number is, it wouldn't make it's a mystery why it can't be reduced to a number, right? Like, what happens when you divide by 0? Oh, it's so mystical and magical. No, it fucking isn't if you understand what's happening. You have to track the units, and then you have to look at the logic of how the units operate with respect to each other. When you do that, now you can see when division by 0 makes sense and when it does not make sense. Sometimes it does make sense. Sometimes it does not make sense. like a win-to-loss ratio, if you lose none of the time and you win all of the time, it's going to be a division by zero, but it makes perfect sense. It's not a number. Right? It's not going to be a number. Right? 6 wins to 0 losses, you can't abstract that to a number. It doesn't make any fucking sense as a number. Similarly, 0 wins to 6 losses isn't a number either, even though it would be 0 divided by 6. That's still not a number. Right? The ratio cannot be abstracted to a number in this case. If you try to abstract it to a number, you're going to get nonsense every time. Even when it looks like, 2/3 or something. Yeah. Yeah. I don't know. I thought that was interesting. I was thinking about that today. And yeah. I think that kind of clarifies, when you understand what the fuck I just said, it clarifies why division by zero is a problem for math. And also that fractions are not numbers. It clarifies both of these things at the same time.